The next property we're looking at is a unit vector in the direction of a vector v. So we say that if vector u is defined by vector v divided by the magnitude of vector v, or we can rewrite this as 1 over the magnitude of vector v times vector v, then u is a unit vector. So we know that that means that the magnitude of vector u is 1. So in other words, the magnitude of vector u is equal to 1. So this is an important property that we're often going to use, again, throughout the semester. So let's go through the proof. So to begin, we want to suppose that this holds true. So we suppose that vector u is defined as 1 over the magnitude of vector v multiplied by vector v. And this is for all vectors u and v in Rn. So if we are supposing that this holds true, then the goal here is to show that u is therefore a unit vector. So we want to show that the magnitude of this vector u must therefore be 1. Okie dokie. So with this in mind, where do we go? Well, we know that by definition of the magnitude, that the magnitude of vector v is a scalar. So 1 by the magnitude of vector v is a scalar or a constant. So let's just make a little love note to ourselves. We know that 1 over the magnitude of vector v is a real number. This is a constant or a scalar. They mean the same thing. So, for the sake of simplicity, let's go ahead and let c be this scalar 1 by the magnitude of vector v. So then we can rewrite vector u, which we have previously defined as 1 by the magnitude of vector v multiplied by vector v. And we're now going to replace 1 by the magnitude of vector v with c. So we have c, our scalar, multiplied by vector v. Alrighty. Well, keeping our goal in mind here, let's go ahead now and compute the magnitude, or find the length of this vector u. Let's give ourselves a little bit more room here. So we want to compute the magnitude of the vector u. So we have vector u is equal to our scalar c multiplied by vector v. So we are finding the length. So whatever we do to one side, we need to do to the other side. So we have the magnitude of vector u is equal to the magnitude of the scalar multiple c times vector v. Now, by the length of a scalar multiple property, we can go ahead and actually rewrite this by pulling that scalar multiple c out to the front. So now we have our scalar c multiplied by the magnitude of vector v. Well, since we let c be 1 by the magnitude of vector v, then we can say now that the magnitude of vector u is equal to 1 by the magnitude of vector v, right, for c multiplied by the magnitude of vector v. And would you look at this? The magnitudes cancel each other out to 1. Woohoo! And we're left with 1, which is exactly what we wanted. Since the magnitude or the length of vector u is 1, this implies that vector u is a unit vector. Hooray! So our final conclusion. So therefore, if we define vector u as being equal to vector v divided by the magnitude of vector v for all vectors u and v in Rn, then the magnitude of vector u is equal to 1, and therefore u is a unit vector. Hooray! And so that completes our